I'll be explaining to you a problem of nodal analysis with dependent sources. Here, the question is find the voltage across the 5 ohm resistor in the network shown in the figure. Here, this is the 5 ohm resistor. Therefore, we have to find V1. So, looking at this question, we can see that there are two unknowns, V1 and I1. So, initially, we need two equations. We have to find two unknowns and therefore we need two equations. Therefore, initially we can write the nodal analysis at node V1, KCL at node V1. Minus 2, that is the current is flowing into the node V1, therefore we are taking it as minus. And in all other branches we are considering the current is moving out of the junction, therefore we can take it as positive. Therefore plus V1 by 5 plus V1 minus 30 I1. Therefore, we can write it as V1 plus 30 I1 by 10 plus, coming to the next branch, V1 minus 50 by 2 resistors are there. These two resistors are in series and therefore we can take the sum of these two resistors and put it as 30. So we can write it as V1 minus 50 by 30 is equal to 0. The second unknown here is I1. How can we write I1? We can write I1 is equal to, from the question we can see that V1 minus 50 by 30. So we can put I1 here. Therefore, there is only one unknown. Finally, there is only one unknown and therefore the equation will be like minus 2 plus V1 by 5 plus V1 plus 30 into V1 minus 50 by 30 the whole divided by 10 plus V1 minus 50 by 30 is equal to 0. So 30 cancel. Then now we can regroup it as V1 into 1 by 5 plus 2 by 10 plus 1 by 30 in plus minus 2 minus 50 by 10 minus 50 by 30 is equal to 0. So we will get V1 is equal to 20 volt. Okay, this is the voltage across the 5 ohm resistor. This is another example of nodal analysis, but here there is a difference. This is a different problem. Here we can see that there are the two nodes V1, V2 and V3. Here we have got a voltage source of 5. Okay, so here we have to apply a different type of nodal analysis, that is super node. We have to consider these two nodes as super node. So we can write the equation at node 1 first. KCL at node 1. At node 1 we can write it as usual, that is minus 4 plus V1 minus V2 by 0.33 plus V1 minus V3 by 0.5 is equal to 0. That is node 1 equation. So now we have to consider the super node V2 and V3. KCL at super node V2 and V3. So we can write it as, before writing the KCL, we can write the relation between V2 and V3. V3 minus V2 is equal to 5 volt. This is another equation. Now we can write the KCL for the super node. That is V2 minus V1 by 0.33 plus V2 by 0.2 plus V3 by 1 plus V3 minus V1 by 0.5 is equal to 0. So this is equation number 3. So we got 3 equations. So we can rearrange equation number 1, 2 and 3. Equation 1 can be rearranged as 5.03 V1 minus minus 0.03 V2 minus 2 V3 is equal to 4. That is equation number 1 rearranged. Equation number 2 is minus V2 plus V3 is equal to 5. This is equation number 2. And the third equation can be rearranged as minus 5.03 V1 plus 8.03 V2 plus 3 V3 is equal to 0. This is equation number 3 rearranged. So we can put these 3 equations in the calculator, 3 equations and 3 unknowns, and you have got options to solve that in the calculator, and you will get V1 as minus 2.62, sorry, there is no minus, 2.62, and V2 is equal to minus 0.17, and V3 is equal to 4.83 volt. Do it yourself, and if you have any doubts, you can ask me. And in the next class, I will be explaining to you the super node with dependent sources analysis. Okay, thank you.